In this video, we're going to learn how to solve quadratic equations with imaginary solutions. So let us look at these two examples. So one thing that you have to remember is that the root of a root of negative 1 is denoted by I. So this is a concept that we're going to apply across the examples that we're going to test. So let us start with the first one. So we have x squared plus 4 is equal to 0. So for us to solve for x, we have to make it the subject of this formula. So we're going to have x squared is equal to negative 4. Remember, the sign changes when a number or any expression crosses the equal sign. So the next thing here will be to get the square root of both sides of the equation, so that we have x is equal to plus minus the root of whatever we have under this root. But remember, we can rewrite that particular root as a product of two roots. That is root of 4 times root of negative 1. So that x is the same as root of 4 is plus or minus 2. And then as we said here, that root of negative 1 can be noted by I. So this means that the value of x is either positive 2i or negative 2i. So let us look at the equation on the right. So we have 16x squared plus 81 is equal to 0. So again, we make x the subject of the formula, where we're going to have 16x squared is equal to negative 81. So we divide both sides by 16, so that we have x squared is equal to, this will be negative 81 over 16. So the next thing would be to get the square root of both sides of the equation. So on the left hand side, we're going to have x, and then we can write this root as a product of 2, such that we have root of 81 over root of 16 times root of negative 1. So root of 81 is 9, while root of 16 is 4. And then root of negative 1, as we said here, is denoted by I. So it means, therefore, that x is equal to plus or minus 9 over 4i. So this just implies that x can be positive 9 over 4i, or x can be negative 9 over 4i. So the case we have dealt with is just binomials, where there are only two terms. So let us look at a situation where we have more than two terms, so that we see if the same thing applies in all these cases. So let's use other examples. Let's say that now you want to solve for x squared plus 2x plus 5 is equal to 0. And we can add another example, that is 2x squared plus 3x plus 7 is equal to 0. So let us solve these two to see if the same applies here. So normally we'd factor, or we use factorization method to solve for such equations, but we'll require two numbers whose product is a, c. In this case, the product would be 1 times 5, which is just 5. But then the sum of those two numbers must be 2 in this case. So there are no such numbers. So it means we're going to apply the quadratic formula. And remember, the quadratic formula is given by minus b plus or minus the root of b squared minus 4ac, and that is over 2a. So all we need to do is just identify the values of A, B, and C. And in this case, the values of A will be 1, B is 2, and C is 5. If you write this in standard form, you'll get A is 1, B is 2, and C is 5. So let us just substitute for those values in the equation or in the formula. So we have minus B, and B is 2, plus or minus the root of B squared, and B is 2, so that is 2 squared, which is 4, minus 4 times A times C, that is 4 times 1 times 5, which is just 20. And that is over 2A, and A is 1, so that is just over 2. So we're going to rewrite that here. So we have minus 2 plus or minus the root of 4 minus 20, which is negative 16, and that is over 2. So what we can do is we can rewrite negative 16 as a product of two roots. So that we have minus 2 plus or minus root of 16 times the root of negative 1, and put that over 2. So that is minus 2 plus or minus root of 16 is 4, and root of negative 1 is denoted by I, and that is over 2. So if we simplify this, we're going to get that to be minus 1 plus or minus 2i. So this means that the value of x is either minus 1 plus 2i, or it is minus 1 minus 2i. So let us also solve this other equation and see if the same thing applies. So we have 2x squared plus 3x plus 7 is equal to 0. So again, we are just going to apply the quadratic formula, because if we try looking for two numbers whose sum is 3 and their product is 2 by 7, let us see if that is workable. So 2 by 7 is 14. So we have 14. So let us see how many ways you can use to get 14. So the first one is by multiplying 1 by 14. And if you try adding 1 to 14, it is not 3. The next one will be 2 and 7. By adding the 2, you get 9, which is not 3. So it means we cannot use factorization method for this. So we go back to the quadratic formula. So let us use the quadratic formula. So let us just identify the values of A. A in this case is 2, B is 3, and C is 7. So if we substitute those values here, we're going to have minus B, that is minus 3, plus or minus the root of B squared, that is 3 squared, which is 9, minus 4AC, that is 4 times 2, which is 8, times C, which is 7, that is 56. And the all of that is over 2A, and A is 2, so it means that it's over 4. So let us simplify this. So x would be equal to minus 3 plus or minus the root of 9 minus 56, and that is minus 47, and that is over 4. So again, we can express the root of negative 47 as a product of two numbers, so that we have minus 3 plus or minus the root of 47 times the root of negative 1 all over 4. So that we have minus 3 plus or minus root 47 I over 4. So it means therefore that the value of x can be minus x plus the root of 47I over 4, or it could be, when this is negative, that is minus 3 minus the root of 47I over 4.